next up we have KIOXIA, they're headquartered in Tokyo. They are a spin-off of Toshiba, and they are the inventor of the NAND flash memory technology. And to speak to us a little bit more about that today, we've got Frederick, who is the Senior Manager of SSD Marketing and Engineering. Frederick, as the head of SSD Marketing, he's spent 10 years within the storage industry, and 2015 was the first year he was here at CloudFest, formerly World Hosting Days. I'd like to welcome Frederick to the stage.
Thank you very much for this nice introduction. Good morning, everybody. So in preparation for this keynote, I was considering technology hypes of the past couple of years, which would not have been possible without cloud technology. And two, which I find very fascinating, I want to share with you today. And the first one are non-fungible tokens, unique digital assets that some people are ready to pay fortune for. So NFTs are stored, managed, and traded on blockchain networks which are hosted on the cloud. And for me, one of the most fascinating NFTs are CryptoPunks. Does any one of you have an idea what's the price tag on the most valuable CryptoPunk in 2022? It's almost $24 million. That's amazing. And the reason for that is, I checked it, it's, quote, the fact that it wears a blue bandana. After I told this to my kids, they are literally wrapping blue bandanas around everything nowadays and trying to sell it to me. But anyway, another technology hype which went really huge in 2022 would not have been possible without a scalable cloud infrastructure. And I'm talking about AI chatbots. So ChatGPT reached 100 million users within the first 2 months after its publication. And that's a number that the phone took 75 years for. And ChatGPT is everywhere. It's even listed as a speaker here at CloudFest. That's probably the case because many of these speakers got some help in preparation of the keynotes. And so I wasn't shy to use ChatGPT either. And I asked ChatGPT, what's the reason why CryptoPunks with blue bandana are so valuable? So I spare you the answer. It's pretty long and can probably only understood by people who are CryptoPunk obsessed and wealthy enough to spend millions on something that wears a blue bandana. By the way, if you have someone of that kind in the audience, let's have a chat later on. My kids may have something interesting to offer for you. But regardless of the technology hype, one thing is for certain. Cloud spending, end-user spending on cloud services is going to increase about in the next couple of years. So Gartner is predicting the worldwide spending to increase by more than 20% in this year on public cloud services. And with more and more companies adopting and moving towards cloud services, the 5-year CAGR is around 20% as well. And infrastructure, software, and platform as a service are the largest and the most growing segments within the overall cloud services. And infrastructure on its own is growing by more than 30% in 2023, which offers a good opportunity for companies which are in that space. And here at CloudFest, we should have some around. And infrastructure consists also out of hardware components. And what hardware component is one of the most impactful and most positive components for cloud applications? I asked that to ChatGPT, and it only took me 2 preceding suggestive questions to ChatGPT to get solid-state drives as the answer. But I agree. ChatGPT compares solid-state drives to traditional hard disk drives, where SSDs provide faster reads and writes than traditional hard disk drives. They offer lower power consumption, greater durability, and they consume less physical space than hard disk drives. And thus, they offer more efficient use of the data center space. And therefore, they contribute also to cost reduction, depending on the application. And I want to go into that a little bit more into detail into this point. But before I do so, let's have a quick look what's inside the SSDs that makes them so compelling. And that's the NAND flash technology. 36 years ago, KIOXIA has invented the NAND flash technology, and it was a landmark in technology innovation. It has replaced ever since many storage media, such as photofilms, cassette tapes, or magnetic tapes in general, compact discs, prints, or even books, and hard disk drives in many, many applications. But also it's offering and enabling applications that we see today, which would not have been possible without it, like smartphones, ultra-portable PCs, video drones, wearables, many, many applications that can only do the job that they do today with this non-volatile memory technology, which comes in a low space or a small space with low power consumption and in a non-volatile memory technology. And KIOXIA maintains to be a leader in the NAND flash and SSD industry by developing cutting-edge flash technology and by operating factories which are producing 1/3 of the global NAND flash demand. And the demand is huge. Gartner predicts that already next year, the NAND flash consumption over all applications will be more than 1 zettabyte. And 60% of that is going into solid-state drives. And the majority of these solid-state drives are used for enterprise, data center, and cloud applications. And that means KIOXIA SSDs are pretty widespread in the cloud. And now, something we're very proud about at KIOXIA is that KIOXIA SSDs go even beyond the cloud up to space. So has our partner, HP Enterprises, developed a so-called spaceborne computer, which is going up to the ISS and supporting scientists in their experiments on the ISS. And this removes the necessity to send data back and forth between ISS and Earth, and enables the scientists to keep the data, store them, and process them right there at the edge at the ISS. And these computers utilize 200 terabytes of KIOXIA SSDs. And these SSDs are standard SSDs from our lineup. They have no special treatment, no tweaking, no screening whatsoever. This is standard SSDs from our lineup. So that shows that KIOXIA SSDs are robust enough to withstand and survive the transport up to ISS, where it's going to be pretty cold during the transport. They are reliable enough to allow the usage on an application in an environment like the ISS, where you can't have lots of spare parts. They are energy efficient enough to fit into the 500-watt power budget, which is given for that computer and which is given by the solar panel power generator of the ISS. So whatever demanding mission you have in mind, KIOXIA SSDs are a good option for you as well. But coming back down to earth, and back to the comparison between hard disk drive and SSD, which we were talking about before. So solid-state drives have replaced hard disk drives in many, many areas where fast data transfer rates, low endurance, low power consumption, and mechanical robustness are key aspects for the application. But there is one large domain where hard disk drive usage is still king, and that's the nearline storage. And the nearline storage have been only a hard disk drive domain because of the low price point that this application requires. But now in the last year, the prices for solid-state drives went dramatically down. And with that, it may allow a new consideration of a total cost of ownership contemplation and having a look onto whether it makes sense to use solid-state drives even in a nearline storage scenario. So let's have a look to that and build a rack which consists out of 3 scenarios, which represent the legacy, the present, and the future. And compare about these 3 scenarios over 4 parameters: the density per rack space, storage density per rack space, idle power in watts, efficiency in megabyte per second per watt, and the relative price per gigabyte between the scenarios. So large and dense JBODs can hold up to 90 hard disk drives, 3.5-inch hard disk drives. And they consume 4 U of rack space. Actually 1 U more, because you need a storage server to utilize the storage also somehow. Hard disk drives nowadays are available with up to 20 terabyte of capacity, which gives you a total of 1.8 petabyte in a 4 U, or around half petabyte per U, to break it down on the rack unit. When 90 hard disk drives are spinning, idling, they consume around 500 watt of energy, and a little bit more when they're active. And when they're active, they offer a efficiency of about 40 megabyte per second per watt. And let's take the price per gigabyte on that JBOD as a base to compare to the other scenarios. In our second scenario, we're looking at a 1 U storage server, which already utilizes the CPU and the DRAM, and can hold up to 32 U.2 SSDs. And that Supermicro reference is a vital option for that. This is a SKU that is existing in one of our partners. And U.2 SSDs can nowadays hold up to 32 terabyte of raw capacity, which gives us 1 petabyte in a U, so double the density in this scenario per U. And 32 U.2 enterprise SSDs consume around 1/3 of the idle power of the 90 hard disk drives. Of course, much more when they're active, but also they have a much higher performance. So overall, we're looking at a 10 times higher efficiency per watt, in megabyte per second per watt, over the hard disk drive-based system. And with the recent price drops, we are looking at a relative price point between the hard disk drive and the SSD of 4 to 7 times the price per gigabyte, or even lower than that. And in our third scenario, we're looking kind of into the future. There's already a Supermicro reference existing, you see there, which is able to hold up to 32 E1.L PCIe devices, such as E1.L SSDs. And soon, in the future, there may be SSDs which support 64 terabyte of raw storage in an E1.L form factor. This doubles again the density to 2 petabyte in 1 U. The idle power is somehow in the same range. We can expect that these large and dense SSDs have a lower performance, so that the efficiency is a little bit lower than in scenario 2, but still 5 times higher than compared to the hard disk drive-based system. So the price per gigabyte we have to see as soon as these SSDs come to market in comparison, but the relative price per gigabyte is one point which only tells about the capital expenditure on the component level. But for a total cost of ownership contemplation, we also should take into account the JBOD that we are saving, the power savings that we have, and the rack space that we're saving. And even more important these days for many organizations and companies is a point that most of the companies have a priority point on their agenda today, and that's sustainability. And with these arguments that we just have seen before, 70% of idle power saving and 10 times higher efficiency in megabytes per second per watt, and even hugely better on IOPS, even though IOPS maybe not really a scenario for nearline storage. But anyway, just to have it mentioned, and a saving of factor of 4 on the rack space means you can utilize your racks much better, you can utilize the white space of your data center much better, and that means it takes much longer until you need to build the next data center. That is a big plus on sustainability, of course. And we have not talked about rebuild times. In the likely event of a hard disk drive failure, to rebuild a 20 terabyte hard disk drive can take a very, very long time. And within that very long time, it's not so unlikely that another hard drive of the same age in that same pool is going to die as well. And that's what you need to take into account when you consider the dimension of your parity calculation in your RAID and erasure coding setup. With SSDs, however, the rebuild times are much shorter. Not hours, not days, but hours or minutes. And by SSDs, the failure mechanism towards the end of its life is very well understood and mostly comes down to the wear of the endurance. So with much lower rebuild times and much better understanding of predictability of the failure mechanism, you may even consider to reduce the number of parities, which gives you, again, more storage space and better utilization of your rack space. Now, SSDs overall cannot attempt to replace the entire nearline hard disk drive market. That's simply not possible. Enterprise hard disk drive bit shipments per year are 5 to 6 times higher than enterprise SSD bit shipments these days. And with increasing storage demand in the world, it's not likely that this relation is going to change. Any attempt to fully replace the hard disk drives by SSDs would be something like the CryptoPunk's blue bandana for SSDs. So it will simply increase the prices like hell, and then the overall consideration doesn't make sense anymore. But for some application like warm storage, cached hard disk drive storage, this consideration may make a lot of sense nowadays. But the usage of SSDs it does not only provide you a plus on your sustainability and a better TCO offering, but it also can help you to design your future-proof IT architecture. Because as you probably have seen, many SSDs nowadays become available in new form factors. So the EDSFF form factor. And that's the enterprise and data center standard form factor that you see lots of SSDs become available in. And this is a defined standard by the SNIA. I'm just putting here the appearance and the images of these drives so that you have seen them once. So there are two categories, E1 and E3. But these form factors are not limited only to solid-state drives. They can be used also by other devices, other PCIe devices, such as network interface cards, DRAM modules, or accelerator cards. And by that, they offer you a higher flexibility in your server because you can have front accessible kind of different devices that you need to plug into your server. And the physical dimension of these form factors offer a better heat dissipation and thus offer a denser design, denser architecture of the server overall, and by that offer more efficiency. And these form factors also have improved the signal integrity and offer higher power envelopes so that you can have depending on the form factor, the allowed power envelope can be up to 70 watts. And this makes these SSDs and devices which are coming in these form factors more future-proof, more powerful, offering more performance, and being ready for next-generation PCIe interface standards such as PCIe Gen 5, 6, and beyond, and even enable computational SSDs, which in future will offload tasks from the CPU to the storage. And with that, if you want to find out more about KIOXIA SSDs, our offerings, and about new form factors, I invite you to come to our booth, C02, here at the fairground, where you can also check out the demo systems and use cases that our partners, Exertis Enterprises, PrimeLine Solutions, together with G-Rate, and Croyd are offering around KIOXIA SSDs. And I ask you don't miss the session of PrimeLine Solution at 2:30 at the Rock Cafe, where PrimeLine unleashes the potential of NVMe SSDs with GPU rate, and our partner Croyd, who does a rethinking of storage management with a focus on reliability, simplicity, and flexibility at 2:55 in the Rock Cafe. And with that, I wish you a successful and exciting time here at CloudFest, and I thank you very much.
Oh, wonderful. Thank you, Frederick. I appreciate that. Great presentation. Okay, now hold on a sec. Okay. You got some SSD drives that are going to the space station.
Right.
Okay, now, so here's the thing. Here's the question. All right. Are they just, how are they different? How did you modify them so that they could work in the space station?
So these SSDs that we're going up to send there to ISS are standard SSDs from our lineup.
Hold on. No. All right, so when you see, like, who watches race cars? Like NASCAR or Formula One, right? Nobody? I'm the only guy? Come on. All right, there's a few of you out there. Okay, so when I hear like, oh, hey, this is the Chevy, car with a nice Chevy engine in it. Now, and I know that the engine in that race car has nothing to do with the race car, with the engine that's going to be put in the car if I bought a Chevy, right? So you're saying that the SSDs that you're sending to the space station are just your off-the-shelf, your normal product?
That's correct, yes. So one of the key points to operate IT architecture or IT components up there on ISS is that you have to have reliable components. And KIOXIA SSDs are designed or specified for a mean time to failure of 2 to 2.5 million hours. That's the reliability figure that we give in specification.
Can I get one from my Mac? Because it's filled more often than that. But go ahead.
Sure. Yeah. And our partner HP Enterprises is using our drives a lot. So they have actually observed that the failure rate of our SSDs is much lower than what we are specifying. So it makes them the best option to send them up to space, onto the space station and support that reliability.
So the people here, we got about, probably close to 100 people in here right now. So we got cloud service providers, we got hosting service providers, we got managed service providers. Why should they care?
Yeah, sure. I'm sure no one of you actually are operating a space station, I think. But some of you may operate a data center. So what is in for you on that? And the reliability of a component means for you that you don't need to replace drives as often. You have components which are just running. That means for you longer uptime, so you have better quality of service to your customer, give you a better reputation at your customer base, and also it saves you labor cost in your data center, as you don't have to replace components all the time. That's essentially it.
That sounds cool. I appreciate your time, and anybody talks about space stations gets my attention. Everybody, thank you, Frederick.
Thank you.
Cheers.
Thank you. Bye-bye.